G'day everyone and welcome back. Sorry for the delay in between videos in this series. I've been working on a few other projects over the past few months, and one of those projects is something I hope to turn into a full game. Hopefully I'll be able to get a devlog video uploaded about that soon. So in the last video, we gave our enemy agent a way to patrol around the map. In this video, we're going to continue the topic of AI by writing a new behavior for our enemy. This time we're going to create the attack state for Qbert, and we're also going to need to create the logic to transition from the patrol state to the attack state. So let's start by opening up our enemy script. And in here, we're going to start by setting up the transitions between states. To do this, we're going to need a few more variables at the top of the class to create this new logic. So we're going to want to create a private game object, and this will be a reference to our player game object. We want a public float, and this will be for our enemy's sight distance. And we'll set this to equal 20. And another public float for our enemy's field of view. And we'll set this to equal 85. Now we'll head down into the start function and we'll make sure that we're assigning the player game object. We can do this by typing in player is equal to game object dot find object with tag. And in here, we'll pass in player. Now remember in the first video, we gave our player this tag. And this function is going to search through all of the game objects in the hierarchy and return the first game object it finds with the tag player. So this function can become a bit costly as our scene gets more populated, but if we're just calling this in start, then it will only be called once and it shouldn't really affect the performance. You wouldn't want to call this function inside of update, as it will search through every game object every frame and will eventually cause some significant performance issues. So back in the script, let's head down to the bottom and we'll create a new function. We want this to be public. We want it to return a boolean, and we'll call this canSeePlayer. In here, using the variables we just created, we're going to get this function to detect whether or not the player is in range and within the field of view of our enemy. So first up in this function, we want to do a null check on the player. And then we want to make sure that the distance to the player is less than our enemy's sight distance. So is the player close enough to be seen? We can do this by using the vector3.distance function. So if vector3.distance, this function takes in two parameters. For the first one, we'll pass in transform.position, which is our enemy's position. And for the second one, we'll pass in player.transform.position. Now, vector3.distance will return us a float that we can use to check against our enemy's sight distance value. So we'll make sure that the distance to the player is less than sight distance. Then in here, we want to create a local vector3. We'll call this target direction. And this will be equal to player.transform.position minus transform.position. Using this value, we can calculate the angle from our enemy to our player. So we'll create a new float. We'll call this angle to player. And this will be equal to vector3.angle. We'll pass in our target direction. And we'll pass in transform.forward. So next we want to calculate if our player is within the bounds of our enemy's field of view. So we want to check if angle to player is greater than or equal to the negative field of view value, and angle to player is less than or equal to field of view. So at the top of the script, we've assigned our field of view value to 85. So what we are checking is if the angle to our player is greater than negative 85 and less than 85, then our player is within the bounds of our enemy's field of view. Alrighty, so with these conditions met, we can now use a raycast to determine if the enemy's line of sight is blocked by an object. So let's create a new ray, and we'll just call this ray with a lowercase r is equal to a new ray. For the origin, we'll pass in transform.position, and for the direction, we'll pass in target direction. We'll make sure to debug our ray just to make sure that we know it's working. So debug.drawRay, ray.origin, and ray.direction multiplied by sight distance. Now at the end of this function, we'll just temporarily return true, and we'll call this function inside of update just to see if it's working. We'll save that, we'll head back into Unity. And I'm going to set the speed value on the navmesh agent to 0. And I'll hit play. So now Qbert is just standing there, but they are still running the patrol state logic. Once we are close enough, and if our player is in front of the enemy, then a raycast should be drawn. So you can see that once I'm outside of the field of view, then the raycast is no longer drawn. And if I get outside of the sight distance, then we stop drawing the raycast as well. So everything's working so far. If everything's like this on your scene, then everything is going smoothly. So now we'll head back into the enemy script and we'll remove the return true line. And then after the line where we create the ray, we'll create a new raycast hit. We'll call it hit info. And we'll assign this to a new raycast hit. Now we'll do a raycast check. So if physics.raycast, we'll pass in ray, then we'll store the hit info. And for the distance, we'll pass in sight distance. In here, we want to check if our hit info.transform.gameObject is equal to player. Then we want to return true. Otherwise, all the way down the bottom, we want to return false. Alrighty, so to quickly run over this again, we're checking the distance to see if the player is close enough to be seen. We're calculating the angle to our player, and then we're checking to see if the angle is within the field of view of our enemy. Then we're using a raycast to check if the enemy's line of sight is blocked by an object. And if all of these conditions are met, then we can return true. Otherwise, we'll return false. So using this function here, we're going to determine whether or not Qbert needs to change into the attack state. Now there's one little issue here that we can easily fix. Currently, the raycast is being drawn from Qbert's stomach. And the way to fix this is at the top of the enemy class, we'll add a new public float, and we'll call this eye height. Now we'll head down into the line where we calculate the target direction. And from the second transform.position, which is our enemy's position, we want to minus vector3.up multiplied by eye height. We'll wrap this in brackets. And we'll do the opposite when we're creating the ray. So for the first parameter, when we create our ray, we want to plus vector3.up multiplied by eye height. And again, we'll wrap this in brackets. So now if we save that and test it out again, we'll walk back up to Qbert. And you can see that the ray is still being drawn from their stomach. But if we adjust the eye height value, then the origin of the raycast will rise. And we can use this value to determine where our enemy's eye line is. But the destination will always be towards our player. Now, one thing I've noticed is that if we walk slightly to the left, the raycast stops being drawn. And this is just particularly with this current setup. Both eyes have sphere colliders on them, and this is interfering with the raycast. So we can either remove these, or we can just assign them to the tag ignore raycast. Alrighty, so now the eyes aren't blocking the raycast anymore, and everything's working as it should. So that value, what was that value again? That was 0.6. So we'll copy that, we'll stop playing, and we'll paste in a value of 0.6 there. Now we're raycasting from our enemy's eye line. We can use this script on different enemies and still have accurate results. Now let's create the attack state. In our scripts folder, we'll create a new C# script, and we'll call this attack state. Let's open it up, and the first thing we want to do is make this class inherit from base state. And because it inherits from base state, we're going to want to implement the abstract class. In Visual Studio, you can do this by pressing Control Full Stop and selecting Implement Abstract Class. Otherwise, you can manually type in each of these functions. So I'm going to delete the system.notImplemented exception from each of these functions. And then I'm going to head up to the top of the class and create a few new variables. The first one, we want a private float, and we'll call this move timer. We're going to use this to tell our enemy to move slightly every so often, which will make them a bit harder to hit and add some variation. Then we want another private float, and we'll call this lose player timer. This value will be how long the enemy will remain in the attack state before they start searching for the player. So now let's head down into the perform function, and first up here we want to make sure that our enemy can still see the player. So the can see player function lives inside of our enemy class, and inside of our base state class we've got a reference to our enemy. So we can access this from any of our states by using enemy.canSeePlayer. And we'll wrap this inside of an if statement. So if the enemy can see the player, then we want to lock the lose player timer to 0. And we want to increment our move timer. The move timer is plus equal to time.delta time. And then if our move timer is greater than random.range, and I'm just going to pass in 3 and 7 there. You can use any values that you like. So if our move timer is greater than a random range, then we want to move our enemy to a random location within 5 units. We can do this by typing enemy.agent. And agent is accessing the navmesh agent component on our enemy game object. And then we'll call the setDestination function, and we'll pass in enemy.transform.position plus random.insideUnitSphere multiplied by 5. After that, we'll set our move timer back to 0. So if our enemy can see the player, then we'll increment the move timer. Once the move timer is greater than this random range, then we'll move the enemy to a random location, and we'll reset the move timer, causing this whole loop to start over again. Next, we want to have an else statement, so the enemy cannot see the player. Then we want to increment the lose player timer. We'll check to see if lose player timer is greater than, we'll just say 8. Again, you can pop in anything you like. You could even make this a public value in the enemy class and call it something like wait before search time. So if our lose player timer is greater than 8, then in here, we want to change to the search state. But for now, I'm just going to return back to the patrol state. And a lot of games use very basic logic like this. Either the enemy attacks or it patrols. So stateMachine.changeState. And while I'm here, we can fix up a few issues with the previous design. We'll head into the state machine class. And instead of storing references to each of the states in the state machine, we'll delete all of the references to the patrol state. And in here, we'll just pass in a new patrol state. So instead of holding references inside of our state machine, we can just create a new instance each time we change state. So we'll save that back into the attack state class. We'll create a new patrol state, and that should work fine. We'll make sure to head into our patrol state, and under the perform function, we'll type in if enemy.canSeePlayer. Then we want to change into our attack state. So we can do this with stateMachine.changeState, and we'll create a new attack state. Now let's head into our enemy class, and in the update function, we'll assign current state is equal to stateMachine.activeState.toString. So now in the inspector, we'll be able to see what state Qbert is currently in. So saving all of that, heading back into Unity, we'll change the speed back to 3.5, and we'll hit play. And you can see that Qbert is currently in the patrol state. They're walking around, and if we walk up to Qbert and walk into their line of sight, you can see that they've changed to the attack state. Now, if I walk out of the view, Qbert will return back to the patrol state. Perfect. Now we've got the logic down to transition between different states. While I'm in the editor, in a previous video, I set up Qbert's game object wrong. So this is a good time to demonstrate how to correctly set up your enemy game objects. If we look at the root game object of Qbert, we can see that it does not have uniform scaling. It's got 1 on the X, 2 on the Y, and 1 on the Z. This is because I used this cube for Qbert's body as the root game object, and I parented all of the other mesh objects underneath. But what we want for the root game object is to only have logic components and then have all of our meshes underneath that as a child of that game object. So I'm going to create a new game object, call this Qbert, and I'm going to copy the enemy, state machine script, and navigation mesh and paste it onto this new game object. Now I'm going to remove all of those components from the old Qbert, and I'm going to parent this game object underneath the new game object. We'll set the position to 0, and then we'll move them back into position in the scene. We'll adjust a few of these settings so that they match up with the geometry better. Under here, we'll create a new empty child. We'll rename this to meshes, and we'll parent all of the meshes underneath this meshes game object. Rename the old Qbert game object to body. So now we've got all of the meshes parented underneath a game object that contains all of the logic and also has uniform scaling. So this is how we want to set up our enemy game objects. Now let's give Qbert a weapon. I've got a model here which you can download from the link in the description. I'm going to drag this as a child of Qbert. So let's just position it roughly to where a gun would be. It's a little bit big, so we'll scale it down. And let's give Qbert some arms. There we go, perfect. We'll rename these both to arms and make sure they're parented under the meshes game object. Now let's create another empty game object under Qbert, and we'll name this gun barrel. We want to pop this at the very end of the gun where we want our bullets to spawn. Make sure that's parented underneath Qbert. And now we'll head back into the code. So inside of our enemy class, let's reorganize our variables a little bit. So we'll move the current state down to the bottom. We'll move all of our private references up to the top. We'll add a header attribute just above our sight distance value. And we'll type in sight values in here. Then underneath eye height, we'll create a new header. And we'll call this weapon values. Under here, we want a new public transform. And we'll call this gun barrel. And we'll have a public float. And this will be for our fire rate. And above here, I'm going to add in a range attribute. And I'm just going to pop in 0.1 and 10. So we'll save that. We'll head back into Unity. We'll assign our gun barrel game object. And we'll set our fire rate to something like 1.3. Now let's head back into the attack state. And we'll create a new function called shoot. And now we're just going to debug a message in here just to make sure that it's working. To set up the logic to shoot, we're going to need a new variable inside this script. So at the top of the class, we want a private float. and we'll call this shot timer. Then down in our perform function, after we increment move timer, we can also increment the shot timer. So shot timer is plus equal to time.delta time. And I'll add in some comments here just to make things a bit more clear. All right, so now we want to check to see if shot timer is greater than enemy.fire rate. Then we want to shoot. Also inside of our shoot function, we want to reset the shot timer. So shot timer equals 0. All right, let's head back to Unity and test this out. We'll hit play, we'll walk up to Qubit, and after a few seconds, they shoot us, but then they get bored and they walk away. And this is because we're still calling set destination when the move timer resets. This is causing them to move and look away from the player. So we can fix this issue by locking our enemy onto the player when in the attack state. So in the enemy class, we want to create a property for the player. So we'll create a public game object. We'll call this player with a capital P. And we'll set this to get player with a lowercase p. Now we'll head into the attack state and we'll set enemy.transform.lookat enemy.player.transform. So we'll head back into Unity and we'll test this out again. We'll walk up to Qubit and you can see that they are locked onto the player and they are shooting us every 1.3 seconds. And if I go out of view, I'll hide behind this pillar. We can see that Qubit returns back to the patrol state. Awesome. So far, we have set up the conditions for our enemy to start attacking the player. The player needs to be in range and within the field of view of our enemy. Then the enemy will turn to face and attack the player. And after a certain amount of time, the enemy will lose interest and return to the patrolling state. We've also set up the framework to start creating our shooting mechanic. The last thing we need to do is create a bullet and make it damage our player. To do this, we've just got one more script that we need to write. So let's head back over to the project window. And in our scripts folder, under enemy, we'll create a new C# script called bullet. We'll open this up in Visual Studio. We can delete, start, and update. And in here, we just want to call the onCollisionEnter function. We'll store a local reference to the transform that we're colliding with. We'll call this hitTransform. And this will be equal to collision.transform. Then we'll compare the tag to see if it matches our player's tag. So if hitTransform.compare tag, in here we'll pass player. Then we want to debug.log hit player. Then next we want to call hitTransform.getComponent. And because we've made sure that this is our player game object, we can get the player health component and call the take damage function. Now remember that this function takes in an integer as a parameter. So we can just pass in a value of 10 here, and that will do 10 damage to our player. Lastly, outside of the if statement, we want to call destroy, and in here we'll pass in game object with a lowercase g. So we'll save that. We'll head back into Unity. And let's create our bullet. I'm going to use a capsule for our bullet. So I'll create a new capsule, rename it to bullet. And then I'm going to rotate it on the Y and the Z axis by 90. I'm going to scale it down to 0.03 on the X axis, 0.1 on the Y, and 0.03 on the Z. So now we've got a very basic bullet, and it has a capsule collider on it. Let's go ahead and add a rigid body component and our bullet script that we just wrote. We'll assign it a nice bright material so that we can see the bullet as it's approaching our player. And that is our bullet game object done. Now let's head into the assets folder and create a new folder called resources. And resources is another special folder name reserved by Unity. Anything placed into this folder can be accessed in code using the resources.load function. So in here, I'm going to create another folder and I'm going to call this prefabs. I'll open that up and I'll create a new prefab of my bullet in this folder. Now let's head back into our enemy attack state, and down in our shoot function, there's a few things that we want to do. First up, we want to store a reference to the gun barrel. Then we want to instantiate a new bullet. We want to calculate the direction to the player. And then we want to add force to the rigid body of the bullet. So first up, let's store the reference to the gun barrel. So we'll create a new transform. We'll call this gun barrel. And this will equal enemy.gunbarrel. Then we'll instantiate a new bullet. So this will be a game object. We'll call it bullet. And this is going to equal gameObject.instantiate. For the first parameter, we'll pass in resources.load. And the resources.load function takes in a string as a parameter. So we can access this using prefabs /bullet. We want to make sure to cast this as a game object. The position that we want the bullet to spawn at is the gun barrel.position. And the rotation we want it to spawn with is the enemy.transform.rotation. Next, we want to calculate the direction to the player, and this will be a vector 3. We'll call this shoot direction. This is going to equal enemy.player.transform.position minus gunbarrel.transform.position. We'll make sure to wrap this inside of brackets and then normalize it. And finally, we will add force to the rigid body of the bullet. We can do this using bullet.getComponent, rigid body. Then we can assign the velocity value. Velocity is equal to shoot direction times 40. And this is going to be the speed of the bullet. So you can make this a public value and assign it to whatever you want. Now, when we're adding velocity like this, the bullet is going to head directly for our player. So we'll save it and test it out. We can delete our bullet from the scene, hit play. And if we walk up to the player, you can see that they start shooting us. But what we can do to improve this a little bit is assign the rigid body.velocity to equal quaternion.angle axis. Angle axis takes in two parameters. For the first one, we'll pass in random.range. And we'll assign the min value to -3. And we'll assign the max value to 3. And for the second value, we'll need to pass in vector3.up. Then we can multiply this by shoot direction multiplied by our speed value. So this will add some variation to the direction of the bullet, making it so that the enemies aren't 100% accurate. So we'll save it and test it out. We'll walk up to Qbert. You can see that they're shooting us, and they're still pretty accurate. The higher the number that you use in that random.range, the less accurate the enemy will be. Alrighty, so that is everything that we're covering in this video. Well done if you've made it this far. The tutorials are getting quite complicated now. From here on, I'm going to try and move to a shorter format of video so that I can release them more regularly, and hopefully they won't be too overwhelming to watch. Let me know what you think in the comments section below. I love hearing your feedback, and once again, really sorry for the delay in between videos. As always, like and subscribe if you enjoyed the video, and I'll see you in the next one.